Hello everyone, it's April 13th. Let's don't waste any time and go right to it. Nothing to be of interest here. Alright, let's take a look. What do we have? I need to flatten a nested list iterator. Oh, what the hell? Very complicated. Alright, you're given a nested list of integers. Okay. Each element is either an integer or a list whose elements may also be integers or other lists. Implement an iterator to flatten it. Implement this class initializes the iterator with the nested list. Call next returns the next integer in the nested list. Boolean has next returns true if there are still some integers in the nested list and false otherwise. By calling repeatedly until has next returns false. The order of elements returned by next would be 1, 1, 2, 1, 1. Yep. 3, 1, 4, 6. Okay. This interface allows for creating nested list. Should not implement it or speculate about its implementation. Okay, just don't look at it then. Nested list is going to be nested integer. Okay, so what is the input? A class. It's a list, right? Nested list is a list of nested integers. So, which means a list of nested integers. A nested list of integers. How do I peek inside then if I don't even know its implementation? Holds a single integer, get, but I can call these, right? I can call get and get list. Okay, I think I can call these things. So is integer holding rather than a nested list, get integer, return the single integer that this nested integer holds. If it holds a single integer, return none if this nested integer holds a nested list. Get list, return the nested list that this integer holds. If it holds, otherwise return something. Okay. Let's see. So we have a nested integer, which will look like this. Now we can get, so the nested integer will be this whole thing, right? This whole thing will be a nested integer, which can contain integer or, hold on. No. A nested integer is either an integer or a list of integer. Okay, so no. A nested integer is either an integer itself or a list or a nested list, right? A nested list or an integer. And inside the nested list, it could be, it's the same, another nested list. Okay, that is clear. So what we can do is pick out, so we know this is a nested integer, which could be a integer itself or a nested list, another nested list. So we're going to call, see if it's an integer. If it is an integer, then we take it, and then that's it. Right? I take it, and that's it. If it is not an integer, which means this is a list, then we grab the list, right? Because for this situation, it's going to be I a nested list is going to be a list of nested integers, right? A list of nested integers. So it could be an integer, or it could be a nested list, right? So if it's integer, we get it. If it's a list of nested integers, right? A list of nested integers. And then we go to the list, we iterate each one of them, and if it's an integer, we take it. If it's not, we go deep again, right? Isn't that how it's supposed to be? So we have two situations. If it's an integer, we take it and store it somewhere. If it's not an integer, we iterate it, right? And because it's a list, so each value itself is a nested integer, and each one we run the same condition, right? The same condition. So we want to check, yeah. I mean, these are easy to implement. Hold on. Do you want to do like kind of lazy implementation? Or do you want to get everything? If we get everything, then these two will be very easy to do. Do you want to... Can we even do it? Like, it's a list of nested integer, right? So we can have indices for them. And if we call, I mean, it might be possible, but I think it's just too hard to handle. 500, let's just take it out. Take the whole thing out, and yeah, we're gonna flat the entire thing and turn that into an iterator. And yeah, I think that's possible. I forgot the syntax for the iterator. It's a call next, right? Yeah, we're gonna call next, and then has next will be actually we don't have has next. I think a Python iterator is just calling next. Nah, let's do the easy way when we handle it. All right. It's gonna give me trouble and say, oh, we don't have nested integer. So we're just gonna do a class next integer, just so that I think it won't complain. I'll just pass. All right. We're not gonna test ourselves. So, all right, what do? We're gonna say self dot list equals this. So this is going to be where we store everything. And then we're gonna do, what are we going to do? Nested list says the nested list, right? So what I'm gonna do is flatten. I'm gonna call a function def flatten, and I want to pass a nested list, which is going to be nested integer, right? And we're going to call it self here. So we just call self dot flatten nested list. Okay, now we're going to flatten it. How do we flatten it? We're going to say for ni nested integer in nested list, if ni dot is integer, right? If it's integer, then we say self.list.append get ni.getInteger. All right. Else, if it's not an integer, then that's a nested list, and we call self.flatten ni because it's a nested integer. And maybe that's it. Right? So we flatten will be, so we add whatever the next level is. After we add, we're going to come back here to check the next one. And yeah, I think that's it. Okay, next, so we also need to have self.index equals 0, right? So has next. Check it first. So we're gonna return self.index must be smaller than len self.list. All right. So we can also put self.n equals len self.list. So we do sequentially. So we do this, and then do these two. So this we can just become self.n. If it's smaller, that means we have more. Now when you say if self.hasNext, right? Then we do we need to return next is return. What does next do? PDL until this the order of elements returned by. So return. So we're gonna have to have self.index plus equal 1, right? And then we're gonna return return what? Maybe we don't even need to check. I feel like we don't even need to check because it says by calling until this, so we probably will call hasNext by itself. Yeah, see that? So when the return self.list self.index minus 1. Okay, so this is our solution. Ooh, very unhappy. But that's fine. So we're gonna do here. And let's see what's the test case we have. All right, take a look. And I'm going to delete some of the things that it's not been happy about. Okay, all right, take a look. Runtime error is not iterable. We say that the nest. So ni is nested integer, right? And the nested integer is not iterable, okay? Because the nested, yeah, of course it's not iterable. Oh, it's ni.getList. Of the get list, we cannot iterate ni by itself. Okay, makes sense. Dot get list. Okay, so we're calling dot get list and see. Well, this one works. Let's add more layers inside and see if anything happens. 4, 6, 7. I don't even know what I'm doing here. Just make it very complicated. Let's do here. Let's do this. All right, do very, very, very complicated and test it. Yep, seems to be correct. All right, so edge case 1. Nest list length is 1, which can be this. That's 1. Yeah, I think we're good. Try it. Yep, that's it. Not too hard. Basically just a little bit of recursion here, and that's it. What should we write for this? Just a simple. I mean, the key to solve this problem is to understand what nested integer is. It can either be a single integer or a list of nested integer. Thus, we can write a recursion to solve the problem. If a nested integer is a integer, we extract it and end the recursion. If not, we take the list and recurse on it. All right, and the runtime, because each value is encounter 1, so it's going to be O(n). And what is our time? Yeah, it's not surprising. It's the general solution, 79% ranking. Okay, that's not too difficult. Not too difficult. Which is always good, right? Which is always good. Doesn't provide a solution, but that is fine. We're going to look for other people's solution to see if there is anything worth checking. Maybe this is an easy one. It's just the one level of recursion. Oh, all right. Look at this, flattened binary tree to linked list. Oh, I did this one too. Oh, okay. I don't even remember. 341. Okay. Must be a long time ago. I have 999 here. What do people say? Using stack, real iterator. Oh, he must be writing real iterator, I guess. Ah, yeah, it's true. Oh, yeah, that's a real iterator. Oh, man. This must be difficult to write. Move to the next. Keep the current progress. Yeah, I have to use a stack. I call this and has next and next because has next is optional. Next and then has next. All right, let's take a look. There's stack. Ooh, is that the index? I think that's probably the index. Self.hasNext. I think hasNext is to go to the next position. And then the top of the stack, take it out. And then self the top of the stack, index, increment, and then we get the integer. So you put the nested list into it. Has, right? Our stack, nested, Then if I equals That means what does it mean? I equals len nested list. So it means I equals len nested list s dot pop x equals nested list I, fixed integer turn true. Then we do this, dot append, otherwise return false. So what is this one doing? Has next will run this, which is we take the top, right? We take the top, and then we check if I equals the length. Why do you check? Oh, I think I means how many has been checked. I think that's what it means. I means how many has been checked. Yes, if I equals length, that means all of them has been checked. If all of them have been checked, then we can pop it. So we don't need it anymore. Otherwise, we check the ones that we haven't seen yet. If it is integer, return true, so we end it right there. And then we can get it by taking the I, okay? Otherwise, if it's not an integer, then it must be a list. Then we need to push that into the stack, right? So we increment, yes, because we checked this already, so we need to increment, and then we push the current one in, and then, oh wow, so that append, and then we need to keep going. So we keep going until we either return false, let's reach the end, or we find the first integer. Wow, we can implement this. I think we can, and then as we implement it, it will give us a better idea of what this one means. But very good. Well, it does copy a sum, but it's not all of them. It's not all of them. I think that's the case. It's not copying all the data in. It's copying the data until the first integer, until the list that contains an integer. It's like anything more is not copied in, right? I don't think anything more is copied in. No, I don't think so. Okay. If we call has next again, so we go in the stack and then we check the top. Yeah, and otherwise we pop it. And then we do the next one. Yeah, I think, yeah, it's, well, it does copy everything, right? I mean, when you append, it copies everything. Imagine we have a list. Yeah, it does copy everything into it, right? So, because the nested list is already in there. It's already in there. So I don't think this is actually necessary. Well, it's a good solution, right? It's a good solution, but it does copy. When you call this, everything is already in the memory. Oh, okay. Fair enough. Yes. Fair enough. So yeah, nothing is copied. It's just reference. Not sure about this though. But anyway, we understand the premise for this. As it carries this one, we'll need recursion to solve, but since we need to access each, use a stack. we push all to the stack from back to front. So we pop the stack. First element. If it is integer, we will return true and pop the element. If it is a list, we will further flatten it. So is this the same as ours? We have a stack. Oh, we can actually, oh no, that's fine. Pair stack, dot push, dot get I. So push everything into it, into the stack, right? And then we say has next. Stack's not empty. We're gonna peek, see if it's an integer. All right, if it's not an integer, we're gonna pop it and then prepare it again. I think this is the same solution. I think this is the same solution, right? So every time, if it's an integer, we end it, and then on the return, right? It's like here. If it's integer, then we just end it. But it didn't really. It saved stuff in the stack. I mean, this is like our stack. Slightly different. Slightly different. It put everything stack.pop and then prepare and then push into the stack. No, I think it's the same. Push into the stack. Hold on. I think it's slightly different, right? It didn't really flatten everything. Because every time it calls has next, it push everything into it, and then push everything into it in the reverse order. All right, and then when you check it, if it's a list, you push everything in the reverse order, and then when you check it, you just pop. So yeah, so I think that's the same spirit as Pacman's idea. I want to implement this one. Each proceed. That's in 2018. As next doesn't change the state, and next could be called multiple times. You should be able to call next multiple times, right? Yeah, you should be able to call next multiple times. But every time you call next, you should call has next. Yes, every time you call next, you should call has next, so you can move forward. Okay, let's try it. This will not be easy. Oh, it has a generator solution. Anyway, let's think about it. So we have the original one, right? And we want to basically remember where we are, and we have a stack, right? And then we can go from back to front. So every time we just pop. So we want every time we pop, the thing's gonna be popped will be the most recent one, right? So we need to insert, right? So it's either it's a list of nested integer. So a nested integer is either an integer or a nested list itself, right? So when we push into the stack, we're gonna push from the back to the front, right? From the back to the front. So we're gonna push it in, and now when we call next, we need to call has next, right? To move our current position. So the top of our stack should always be the next integer after we handle it by calling hasNext. So if it's integer, if it is integer, we just pop it, no problem. If it is not an integer, which means if it's a list, it's nested list, then we need to push it back in, right? We take it out and then reverse push it back in. All right, that might work. All right, let's try it. Slightly different. So we can say 2. This will be a non-flattened solution. So we just gonna have a stack, right? And then we don't need any of these. So we're not call flatten. We just let's follow that. We just call prepare. All right. We're gonna do this and we don't want to copy. All right, we don't want to copy it. So we just say for I in range len nested list -1 -1 -1 and self.stack.append nested. All right. So this is prepare, which means we want to prepare, and then hasNext we need to traverse to find, which means hasNext we have the stack. Right? I want to check the top of the stack. So how do we know that we have? I mean, when we check it and then we push it in, right? So when we always push in is going to be the integer. So I'm going to say while self.stack, right? While self.stack, and I want to check if self.stack -1 dot is integer, then return true, right? If it's not integer, then we need to say self dot prepare self dot stack dot pop. I pop the top, which is not integer, which means it's a list. So I pop it, and I'm going to push it back in again. So we're going to do that, and once there's no more stack, we're going to return false. And here we're going to call self.stack every single time. Right? We're going to call self.stack. And not self.stack. Self.hasNext. After we call this, we make sure that the top of the stack is a integer. When the return self.stack.pop. Right, so this is just gonna pop. Yeah, let's try this one. So this is not completely flattening the thing. Run it. Hey, that's not correct. All right, let's take a look. Oh, we forgot to say self.prep. Prepare nested list. We have to prepare initially. Nested list has no len. Okay. It's a nested list. Should be a list. Hold on. If it's integer, Oh, .pop.get list. I always forgot about the get list. Yep, I think this one seems to be right. Let's try it. All of them. Yeah, I think this one's correct. Yep. I mean, definitely it's going to be slower, but I think this fulfills the requirement. I think this is basically, I think, what they want. So yeah, nothing is flattened, right? Not non-flattened solution. So basically, inside a stack, it's either integer or reference to a nested list. And the size of self.stack is always smaller or equal to the fully flattened list. Yep, good. This is the official correct solution. All right, that's it. Good. We write two solutions. I like this because the Pacman solution, he kind of write this recursion, not recursion. I think his solution is a little bit more complicated. This is good enough for me. All right, that's it. Did pretty well, and I'll see you guys tomorrow. Adios.